For our case study, we have selected TF Value Mart was located in Bidor. We specifically chose this location because it is located near us, which made it very convenient for our group to visit and conduct a detailed hands-on observation of the service system. Looking at the operating hours, this supermarket operates daily from Monday to Sunday, starting from 10 a.m. until 10 p.m. This 12-hour window allows for a consistent flow of customers throughout the week. Finally, regarding the service capacity at the checkout area, there are a total of 8 servers, which is checkout counter. During our observation at 5:40 p.m., we found that only 3 counters were open to serve the customers. Here, some evidence that we take during our observation. There have servers, customer, and the waiting line. Based on the picture, we can see that the customer was queuing before they pay what they purchases.
We are going to start with arrival characteristic. The first one is the size of the calling population, and we chose unlimited, infinite for TF Value Mart Bidor. The reason is, based on our observation, customers continuously arrive from the surrounding public at the TF Value Mart Bidor. The next one is the pattern of arrivals at the system. We see that customers arrive randomly at random time intervals. Last one, we have behavior of the arrivals, where customers generally just join in the queue and wait patiently to be served. There is also rarely bulk or range, because checkout is compulsory to complete their purchases.
Okay, for the waiting line characteristic, there is 2 characteristics, which is the length of the line and queuing discipline. The length of the waiting line is unlimited, meaning there is no limit of customers who can wait in the queue. For the discipline, customers are served based on the first in, first out principle, where the customers are served in the order they arrive, ensuring fairness in the service process.
Now, let's dive into the service facility characteristic. To properly analyze a queuing system, we must first identify the number of channels and the number of phases. First, regarding the number of channels, we have identified this as a multi-channel system. This is because the facility utilizes more than one server to handle customer transactions. Next, looking at the number of phases, this is a single phase system. This means that customers only need to go through one station before they exit the system.
Now, we move on to the queuing system. By the time customer arrive, they will choose their item to buy first, and then they will go to the payment counter to pay. After that, the customer will waiting in a single queue from 3 different payment counters. Each counter serves customer independently, and right after completing their transaction, the customer will be served as a served unit.
The next one is queuing model. For our case study, a multi-channel queuing model is applied to represent the checkout system at TF Value Mart Bidor supermarket, where multiple cashiers operate simultaneously to serve customers. This model is appropriate for supermarkets as customers arrive randomly and are served by the first available cashier. The arrival rate new is 162 customers per time period, indicating a high flow of customers entering the checkout area, especially during busy hours. This reflects strong customer demand and contributes to queue formation. The next one is service rate new is 59 customers per time period, representing the average numbers of customers that each cashier can process within the same time frame. The service rate determines how quickly customers can complete their checkout. And then, the system consists of 3 servers, meaning there are 3 checkout counters operating at the same time. Having multiple servers help reduce waiting time compared to a single counter system. However, when the arrival rate is high, congestion may still occur. Overall, this multi-channel queuing model allows the supermarket to evaluate checkout performance, customer waiting time, and system congestion. The results can be used to assess whether the current number of checkout counters is sufficient or if additional counters or faster service methods are needed to improve the customer satisfaction. So, to evaluate, we will be using QM software and run a queuing analysis. So, this is the result that we get from our analysis. The queuing analysis results reflect the performance of the checkout counters in the TF Value supermarket. The average server utilization is 0.92, indicating that the cashier are busy 92% of the time. This shows that the checkout counters are highly utilized, especially during peak shopping hours with very little idle time. And then, the average number of customers waiting in the queue is 9.12, while the average number of customers in the system is 11.86, including both waiting and being served. This suggests that queues frequently form at the checkout area, although the level of congestion remains manageable. Customers spend an average of 3.38 minutes waiting in the queue and approximately 4.39 minutes in total from joining the line until completing payment. These waiting times indicate that the checkout process is generally efficient, but delays may still occur when customer arrivals increase. Next one, the probability that the checkout system is empty, P0, is 0.02, meaning there is only 2% chance that no customers are present. This confirms that the checkout counters are almost always in operation and experience continuous customer flow. Overall, the results indicate that the supermarket checkout system is well utilized with moderate congestion. While the current number of cashiers can handle customer demand effectively, additional counters or faster checkout methods may be beneficial during peak hours to further reduce waiting times and improve customer satisfaction.
In conclusion, the service system operates efficiently, ensuring that all processes run smoothly without unnecessary delays. Besides that, the number of servers is adequate to meet the customer demand, allowing services to be delivered quickly and effectively. So, as a result, customers are happy and satisfied with the overall service experience.